So in the opener here, we just want to review those two things that we did last week. The first part, we want to write the prime factorizations of those numbers in standard form. That's what the SF stands for, and exponential form. So who wants to help me with the 25? All right, so 25 is 5 times 5. Can I factor those 5s? No. So what do I do when I can't factor it? We circle it, right? So as soon as we get to a prime number, which is a number we can't factor anymore, we circle it. Now we could factor the 5, but the only way to factor it is to use what? 1 and 5, right? And we never want to use 1 because if we start using 1, then it's just going to go on forever. All right, so that's the only way to factor it, so we're going to circle it. All right, so Travion, what is the standard form going to look like? 5 times 5, okay, and then how about the exponential form? 5 squared. Or another way of saying 5 squared would be 5 to the second power. Okay, good. That was a pretty easy one, wasn't it? Nice, easy way to start the week. How about the 48? Who can help me with that one? All right. 6 and 8. All right, now what? Cami? Okay, so 8 is 4 times 2, and 2 is prime, right? Okay.
And 2 and 3 on this side.
Okay, 2 and 3, those are both prime.
And then 4 can go in 2 times 2.
2 times 2, okay, good. Now, we didn't have to worry about this on the last one because they were both the same number, they were both 5s, but what do we need to make sure when we're writing this in standard form? We need to make sure they're in what order? Least to greatest, exactly. All right, so what's that going to look like? Cami? For standard form first. Oh, 2 times, did you say 4 times? All right, so 2 times 2 times 2 times 2 times 3. All right, and then how about the exponential form? 2 to the 4th times 3. Perfect. And if we want an exponent on that 3, since there's 1, 3, we could put a what there? A 1, exactly. So we could say 2 to the 4th times 3 to the 1st if we wanted to, since that is exponential form. But you don't need it. All right, how about the 200? Jayla, you got this one? 20 times 10, I like that. So since it ends in a 0, we know we can multiply by 10. And then the 20 will be what? 5 times 4. 5's prime, right? Okay. 2 times 2. Okay, and then how about that 10? 5 times 2, you said? Okay. Okay, so what's the standard form going to be? Alright, it looks like we got everything. Good. So then how about exponential form? Good. So 2 cubed times 5 squared, or you could say 2 to the 3rd power times 5 to the 2nd power. Alright, how about the 400? Who's got that one? Ryan? Ryan, 400 ends in a 0, right? I'm just going to have you do the first one for me. So since it ends in a 0, what do we know goes into it? Ryan, anything that ends in a 0 can be divided by what? So it's going to be 10 times something. And so Ryan, what do we get when we divide by 10? If we take a 0 off, what's left? So it's going to be 10 times 40. And then the 10, anybody? 5 times 2, 40. 4 and 10, or you could do 5 and 8 if you want, or you could do 2 times 20 if you want. All right, 4 is going to be what? 2 and 2 and the 10? 5 and 2. Okay. So how about standard form? Who can tell me what that's going to be? All right, 2 times 2 times 2 times 2. I think there's 4 of them, right? 1, 2, 3, 4. Okay. Times 5 times 5. So we got 5 and 5. Okay. And then how about exponential form? Libby?
2 to the 4th, 5 squared.
Perfect. We need to evaluate these square roots. All of these square roots are what we call perfect squares, which means that we're going to be able to take the square root of them. So, since these are all perfect squares, we can figure out exactly what the square root's going to be. So a number like 16, what do we square to get 16? 4, right? So the first thing we're going to do to evaluate a square root is we're going to keep it in the square root, but instead of 16, we're going to write 4 squared. All right, and the reason we do that is that a square and a square root are, starts with an I. The square and the square root are inverses of each other, and inverses of each other cancel each other out. Since those are going to cancel each other out, the square and the square root are going to go away, and what's left? 4. All right, so again, when we're evaluating a square root, the first thing we do is we get a square inside the square root, and then that square is going to cancel out the square root, so it breaks out of the square root. So now the 4 is on the outside. How about this one? This one looks a little trickier, but it's actually easier because the radicand, the inside's already a square. Exactly. So all we have to do is cancel the square and the square root, and what does that leave? 7. If you wanted to, you could figure out what 7 squared is, and that would give you 49. But then the next thing you would do is write it as 7 squared. So you'd just be going backwards. Same thing here. This one would be a pretty big number. Anybody know what 27 squared is? 729. Okay, it's a pretty big number. You probably use your calculator to get it, right? But you don't need it because it's already a square, right? So since we have a square inside of a square root, what's going to happen with the square and the square root? They're going to cancel each other out, and that leaves 27.